There are many dangers involved with using pointers in C++, of which you have to be very careful. In C++, we believe very strongly in Murphy's Law that if anything can go wrong, it will. And so when we learn how to type up code in C++, we try all the time to get into the habit of never even allowing ourselves to be in a situation where there could possibly be some problem. We stay away as far as possible from doing risky stuff which can go wrong. And sometimes, maybe even most of the time, even if you paid close attention to make sure that anything that can go wrong shouldn't, it is highly unadvised to get into such bad habits, and many programmers will consider your code unreliable source code, unstable code. So I'm going to try to mention a few of these dangers over here. Let's start with this. I mentioned in an earlier video a little bit about the problem of creating a variable and not initializing it, just creating it just like that. The problem with that is that it could be that later on in your code, before you remember to initialize the variable with something, you maybe are going to try and use that variable to do something. Maybe you're going to try to increment that variable by 1. Or maybe you're going to try to pass that variable into some function which takes a integer variable. Or maybe you'll try to assign this uninitialized variable to another variable, like over here taking whatever is inside x and give it to some other variable. As you can see, we have a big problem over here of trying to use a variable as an expression when we didn't give our variable any number of some sort. Our variable, in a way, is like empty. In truth, if we want to look behind the scenes, what happens over here is that the program will create a variable of type integer in RAM, in memory, and if you didn't assign anything to this variable, then the variable will have inside of it whatever garbage happened to be in that memory location left over from whatever before. So let's say the last thing that used this piece of memory left it over with the number 1 inside, then our variable x will have the number 1. If it had a whole bunch of other garbage, then our variable x will have exactly that garbage. We don't even know what kind of garbage exactly was in there. So for all we know, as of now, our variable x is totally invalid, and we can't expect it to behave normally when we assign it to some other variable or something, because we don't know at all what's inside of it. And you get stuck in a situation called undefined behavior, which means that your program can try to continue running and deal with whatever was inside the variable, but as soon as it hits a point where you were expecting it to have some normal number and really it doesn't, your program will probably end up crashing at some point, and that's it. Or maybe your program will continue running and everything will seem to look like it's running okay, just that our variable will be full of corrupted information, and it will probably spread that corrupted information when you try to assign its value to some other variable, etc., etc. So we don't want to get into a situation of undefined behavior, because from that point on, things go out of control. The same thing, and even worse, is when you create a pointer, just as simple as that, without assigning it to some address of something valid in memory, of some variable, some stuff in memory. Because right now, again, this pointer, which is right now sitting somewhere in memory, has inside of it a whole bunch of garbage which happens to be left over in that space in memory that we just got for our pointer. Right now this pointer continues to have all of that garbage. Nothing really valid that we could rely upon in our program. And if you accidentally start doing stuff with this pointer, like dereferencing it and doing stuff to the variable that you hope it's pointing to, or you pass it into some function, etc., etc., then your program again will be stuck in a terrible UB, undefined behavior, because again we don't know what is actually at the moment inside of this pointer, since we didn't assign anything valid to it. Whatever garbage was in that memory location until now will right now be inside of this pointer. And this can get really, really bad with pointers to memory locations, because depending on which operating system you're using, in the best case, if you're lucky, your operating system will notice that you're trying to use a pointer that's not been initialized, that's not pointing to a valid memory location over which you have control, over which you have permission to access. And in the worst case scenario, maybe you'll accidentally access a piece of memory where some important information useful to some program that's currently running, or maybe even the operating system itself, you could mess up the whole system accidentally by just using this pointer with invalid stuff in it. And again, on the other hand, your program could look as if it's running very well for some odd reason, like maybe you happen to stumble on a piece of memory which had a valid memory address over there, and so your pointer will be pointing to something valid which does work, and your program will continue running and look as if everything's okay, when really you are totally entangled in a undefined behavior situation. And only maybe after a long, long time will you suddenly notice that something's terribly wrong in the program, and that will be because of a uninitialized pointer. So here's the rule. When you create a pointer, the best thing to do is right away assign it to the address of some variable that you created before. If you just create your pointer just like that, and you wait for a little bit later in your code to initialize that pointer, you are allowing yourself the risk of maybe using that pointer before actually initializing it. One half solution to this problem is if you really need to create a pointer to which you have to wait a little bit to assign some address to it, then as soon as you create it, give it right away the number 0. This is right now known as a null pointer. What we have over here is a little way of checking to see if our pointer is valid or not. When we create a pointer and we right away give it the number 0, so we make our pointer a null pointer, from this point forward, every time you try to use the pointer, if you want to make sure, because you may be in doubt that the pointer was initialized with some valid address, thanks to the fact that initially we gave it the number 0, we can now test to see if our pointer is valid or not. Right over here, I want to dereference my integer pointer and assign the number 300 to the variable that's there, that's being pointed to. But before I do that, first I want to check to make sure that my pointer is valid. So I test to see if the inside of my pointer has 0, then I will print out that, sorry, the pointer is uninitialized, so we have a mistake. And only if it isn't 0, which means it does have some valid memory address inside of it, and we know that it must be a valid memory address because the only thing it could have besides a memory address is 0, because when we created it, we right away gave it 0. So in this case, we can safely assume that if it doesn't have 0, then it has a valid memory address, so it's pointing to a real variable, and so I could safely dereference that pointer and do whatever I want with the variable. So this is just a half solution, because we always will have to test to see if it's 0 or not before we start using it if we want to be 100% safe. But we still have the risk that if we try using this pointer when it has 0 inside of it, we again will end up with a undefined behavior situation. So if at some point you forgot to test the pointer to see if it's valid or not, and then you start using this pointer, like over here we're dereferencing a pointer that has 0 inside of it, again we have the same problem of undefined behavior. Just as bad as dereferencing a pointer which didn't have anything at all assigned to it. So try to always either initialize your pointers to some valid address, or give it 0 and then test to see if the pointer is valid. So now we know how to make pointers and use pointers. We know the advantages of using pointers because we could somehow sneak around the limitations of scope, and we also know the dangers of using pointers, of which you have to be very careful. Don't forget Murphy's Law: if anything can go wrong, it most probably will. So I advise you again to take a break now and play around with pointers as much as possible. This is a very essential part of C++, of which you have to be very fluent to know exactly how to work with and how to handle pointers.